So welcome to our next session on measurements of an inductance. So coming to this measurement of an inductance, here we are having two types of an inductance. One is the self-inductance, another one is the mutual inductance. And the devices used for this self-inductances are, the first one is the Maxwell's bridge, second one is the Hayes bridge, and third one is the Anderson's bridge. And the bridge used for the measurement of an mutual inductance is the Heaviside Hamel bridge. Now let us discuss about the measurement of this self-inductances. So the first one is the Maxwell's bridge, and now let us see the diagram for the Maxwell's bridge. So let us consider we are having an 4 terminals, terminal A, terminal B, or it may be a node B and node D. The unknown resistance and inductance, that means the unknown coil, the unknown values coil are connected across the terminals AB, and the known standard values are connected to the between AD, and a known resistance values are connected between the C and D and B and C. Now let us name these parameters. R2, this is L2, and this inductance having some internal resistance R2, this is R2, let us say this is R4, and it is R3, and the voltage source is connected between the terminals B and C. Now the voltage across the terminals B and C is, let us consider it is as E1, and the voltage across the terminals A and D is E2, and the voltage across the terminals B and C3 E3, and between these C and D is E4. Now see here, now L1 and R1 are the unknown values, and L2 is adjusted. L2 is a standard value, which is used for comparing the with an unknown resistor, unknown inductances. So nothing but now this in this method, the unknown resistor, the unknown inductances, this is the unknown value. Unknown inductances is measured by comparing with an standard inductance L2. Now again R3 and R4 are the known values, and R2 is also a known value. But now let us see the impedances for this one. impedance of arm AB. Let us consider that is the Z1, which is equal to R1 plus J omega L1. Similarly, for BC, it is Z2. BC, it is Z2, and AD. Let us consider this is AD. Z2, R2 plus internal resistance plus J omega L2, and BC, that is Z3, which is equal to R3, and CD, impedance of arm CD, Z4, which is equal to R4. Hence, for a balanced bridge, so for a balanced bridge, Z1, Z4 is equal to Z2, Z3. Now substitute this Z1, Z2 and Z2, multiply this all these impedances, then we will get. Now let us again write that expression. Z1, Z4 is equal to Z2, Z3. Now Z1 is R1 plus J omega L1, Z2, Z4 is R4, Z2 is R2 plus small r2 plus J omega L2 into R3. Now multiply all these things and separate the real parts and imaginary parts. So we are getting R1 R4 plus J omega L1 R4, which is equal to R2 R3 plus small r2 R3 plus J omega L2 R3. Now equating the real and imaginary parts, equating real and imaginary parts. So first equate these two things. These are the combined thing. This is the real part, and here it is the real part. So real parts are R1 R4 is equal to R2 R3 plus R2 R3. So the unknown resistance R1 is calculated by R2 plus small r2 into R3 divided by R4. Similarly, now equate the imaginary parts. L1 R4 is equal to L2 R3. Now L1 is equal to unknown inductance. L1 is equal to L2 into R3 by R4. These are the unknown values. Thus, the unknown inductance and resistance may be calculated. But what are the advantages and disadvantages of the Maxwell's bridge? So, first let us consider about the advantages. Coming to the advantages, here the expressions for calculating the R1 and L1 are very simple, and these two equations does not depend upon the frequency, and the R1 and L1 both are independent to each other. These are the advantages. And coming to the disadvantages, here for calculation of these unknown values, we are comparing with the standard inductance and resistances. So here the variable inductor is very costly. Variable inductor is costly. And the size of the variable inductor is bulky also. The variable inductor is bulky. So this is the way how the self-inductance is calculated by using this Maxwell's bridge. Thank you.